All right. So in developmental psychology, we are, non-surprisingly interested in the effects of age on different kinds of outcomes. So we might be studying cognition, or we might be studying physical changes, or we might be studying social development. Whatever it is, we're interested in the impact of age on these different outcomes. So there's different ways that we can design research to allow us to measure the effect of age. The first thing I wanted to mention is the simplest to conduct, and this would be the cross-sectional method. The cross-sectional method would be where, let's say in 2010, you're collecting data, and so you recruit people who are 85, 75, 65, down to 15. So we have our year of birth for each of these people, and we recruit people of these different ages. And then we do something. We administer some kind of test or whatever, and we want to see whether the 85-year-olds score different from the 15-year-olds, for example, or if the 45-year-olds score differently from the 75-year-olds, whatever. Our goal is to be able to make the argument that if the 15-year-olds and the 85-year-olds score differently from each other, it's because of development. That, in 70 years, the 15-year-old will in the future be scoring like this 85-year-old is now. Like when that 15-year-old is 85, they'll score the same way as this 85-year-old is. Where we run into potential problems is when we don't make sure that our groups our age groups are equally representing different kinds of characteristics. Like you don't want to have a bunch of 85-year-olds who, had to leave school in order to help support their family in World War II while dad was fighting. Like you don't want to have that compared to a bunch of 15-year-olds who are still currently enmeshed in high school, right? Like any 85-year-old who hasn't taken a test in a really long time is probably going to suffer compared to a 15-year-old who's really, been taking a lot of tests their whole lives and have never lost it. We want to make sure that we're matching groups as much as we can on things like racial things or education level or socioeconomic status when they were growing up, or other factors that we think might have an impact on the outcome, so that the only thing that really differs between the groups is their ages. So we want to do that, but it's really hard. It's really hard to get, 85-year-olds who have the same level of education as the average 55-year-old, right? Who has the same amount of education as the average 25-year-old. Like it's really hard to match them on that, let alone match them on a whole bunch of characteristics that we think might have an impact. And so what ends up happening is the cross-sectional method is very vulnerable to cohort effects, where, the 85-year-old and the 15-year-old might score differently, but it might not be because of development. It might be because of the eras in which they were raised. And that 15-year-old may not grow up to score like this 85-year-old. So that's a definite risk. So there's another way we can collect data. We can design our study. That's the longitudinal method. And that would be where we start collecting data in 1930, and when our participants are 5, and then every 10 years we come back and we test them again, throughout their lifespan. Now, clearly, I have to say this is not going to be the same researcher collecting all this data, right? Because somebody who's old enough to be doing a research study in 1930 is not probably alive in 2020. So obviously they have to pass it down to their graduate students and, other people who will take the baton and keep doing the study. But the fact that the researchers, drop out or die is a good example of a problem with a longitudinal study, which is that the participants may drop out or die, right? And so when you finally in 2020 you're testing them when they're 95 years old, you may only be looking at like the healthiest, the ones who are the most interested in continuing the study, a bunch of things like that make them different from all of those who dropped out. And you might get an incorrect picture of the effects of development, right? You might get an incorrect, an overly rosy impression that, oh, look, people's intelligence doesn't change much, or their reaction time doesn't change that much. But really, you're only testing the healthiest people by the end. And of course, it's really super expensive to do longitudinal research because, I mean, every 10 years I have to find all of these people, test them again. And it takes a long time. Now, this is a ridiculously long longitudinal study. This is not very typical. We'll talk later in class about a study that was actually conducted like this. But most of the time, longitudinal studies are more like, let's study a baby and start studying them when they're 3 months old, test them every 3 months until they're 15 months old. So usually longitudinal studies aren't quite as long as I'm implying with this chart. Maybe you do a longitudinal study of kids who are right around the age of puberty. So maybe you start collecting data when they're 10 and you finish collecting data when they're 15 and you collect data on them, a few times in between there. So it's not usually this long, but it's still expensive compared to the other kinds of ways that we can collect data. Cross-sectional design, you just recruit everybody right now, administer the test right now, and then you're done. Longitudinal, at the minimum, you have to get those people back somehow. And so it's time consuming and it's kind of expensive to run. Now, both of those designs had problems that the sequential design can help correct for. In a sequential design, you start off with what looks like a cross-sectional design. So you recruit, let's say you started collecting data in 1950. So you recruit a group of people who were born in 1925, 35, and 45, and you test them. Then you come back in 10 years, you retest all three of those groups and add a new group of people who were born in 1955. And then 10 years later, you come back, retest all those people and add a new group, and you keep going like that. The great thing about the sequential method is that at every data collection point, you have some comparisons that you can make and you can report. And that's really important for researchers because we all have to get tenure and we all need publications and things like that. So having something to report every time you collect data is a benefit. But it's, subject to the cohort effect, right? It's possible that the differences we're seeing between groups is due to cohort effects. So if we follow through on the longitudinal side, so we have 4 data points on the people who were born in 1925, we can really get a picture of whether the changes that we're seeing are due to development or due to differences between the cross-sectional groups. So the sequential design kind of gets rid of the problem of having to wait so long for data before you can ever report any of it, and it also gets rid of the cohort effect basically. Not perfectly, nothing's perfect, but it's it gets rid of a lot of the complaints that we have about both cross-sectional and longitudinal. All right, so I'm going to do kind of a brief overview of the different research methods that are available in developmental psychology, and I'm going to start with the gold standard of research methods, which is experiments. In an experiment, I'm going to use the example of Bandura's Bobo doll experiment. We're going to talk about that later in the book, so I thought, it's a really nice, clean experiment. Let's go ahead and use it as an example. He conducted this experiment in 1961. He did a little bit of tweaking and redid it in 1963. All right, so first off, you have to have some kind of independent variable. That is going to be a variable that the researcher has control over. So in the Bobo doll experiment, what served as the independent variable was the exposure of the child to an adult behaving in a uniquely aggressive way towards this Bobo doll. If you've never heard of a Bobo doll before, here it is depicted. It's a blow-up doll with sand in the bottom, and then it has on the front and the back, ink print of what looks like a clown. And really, there is absolutely nothing to do with a Bobo doll besides punch it and kick it. Like there's no other function of a Bobo doll. It can't do anything else. So most children, when they play with the Bobo doll, they will punch and they'll kick it. So Bandura gave children free playtime with a Bobo doll to find out what they did do and what they never did. And he never saw a child throw the Bobo doll, and he never saw a child go over to the table, pick up one of the toy hammers, bring it over, and hit Bobo with the toy hammer. So the independent variable was exposing the child to these kinds of aggressive acts that no child spontaneously had admitted or not. So your independent variable is aggressive exposure. And some kids saw this lady beating up Bobo in this way, and some did not. The experimental group is the one that saw her throwing Bobo and hitting him with a hammer. The control group didn't see that. So to make sure that any individual differences between the children are distributed equally across the experimental group and the control group, you have to use a procedure called random assignment. So each child who volunteered to participate in the study had an equal chance of being assigned to either the experimental group, where they saw the adult beating up Bobo, or to the control group, where they didn't see that. That way, if there are innate differences between the children in their level of aggression or experience with Bobo or things like that, if there are individual differences, they'll be distributed across the experimental and the control group. And that gives us a lot more confidence that the two groups started off basically the same. And so if they behave differently in the long run, we're left with the only explanation being that the independent variable caused that difference in behavior. So in the case of the Bandura study, the dependent variable was how often the children displayed the behaviors that the model displayed. And what we're looking for is to see whether the experimental group, who saw the adults behaving in this way towards Bobo, imitated those behaviors. And what you're seeing is a little boy who, almost exactly is imitating the behaviors. So will we see that more often in the experimental group who saw an adult behaving that way than we will in the control group? And like I said, none of the kids spontaneously had displayed these behaviors, as part of a pilot study. And so he was pretty confident that none of the kids would show that were in the control group. And he was right. Like, the experimental group mimicked almost identically the behaviors they saw the adult make, and the control group didn't. And so the dependent variable of, did you do these behaviors? And it would be recorded in numbers, yes or no, how many times did they do these behaviors, showed clear evidence that the independent variable was responsible for the difference between the groups. The benefit of an experiment is that it is the only way to establish causation. We've controlled everything about the situation. So the only thing that we can explain this behavior that we're seeing this little boy do, the only thing that we have available to explain that is his exposure to the lady behaving exactly the same way. So this is the only research method that I'm going to describe that allows us to make such a causal link, that we know what caused what. Now, I say that, but there are a lot of problems with experiments. There are a lot of ways to introduce confounds. And I don't want to go super detailed. I teach research methods and stuff, so I don't like to, bog down in it too much right now, but I'll just say there are a lot of things that we think we've controlled everything, but we might have left some factors uncontrolled that are actually a better explanation for the outcome. Part of why I picked Bandura's study as an example is that really it was a really good, tight experiment that he controlled everything. And the only thing that could possibly explain why the little boy is hitting that Bobo doll with a hammer is because he saw that lady do it. So in his design, he made sure to eliminate as many alternative explanations, or what we call confounds, as possible. Now, another way to collect data is what we call a quasi-experiment. The thing that makes a quasi-experiment quasi means sort of, or not quite. What makes it quasi is that we are not going to randomly assign our participants to condition. We don't have the ability to. Like, for example, here's a study that they've got several things here that are qualities of the participants that they're using as a way to sort the participants into groups. So, for example, we have males and we have females. Well, we can't randomly assign some people to be male and some people to be female. So we have to use their, existence in those groups as the sorting method. Ethnicity, right? We can't randomly assign some people to be non-Hispanic and some people to be Hispanic. They are already in those groups. So this is quasi-experimentation. We don't have control over these variables. Their teacher-rated prior achievement, that's already been determined. We can't randomly assign some of them to be high achievers and some to be medium and some to be low achievers. We can't. They already came to us in those groups. And then the last one on the right, percent of free lunch median split. Well, they divided the groups into those who didn't have free lunch versus those who did. They already came in those groups. We can't randomly assign people to be in those groups. And so in quasi-experiments, we have less control than we do in a real experiment. In a real experiment, we can make those random assignments. So when we talk about quasi experiments, we're going to use pre-existing differences between the people to serve as the independent variable. Now, there's actually an additional independent variable in the design that we're looking at in this panel, and that is whether they were in the treatment condition or the control condition, and that's what those bars represent. So that was the part that the experimenter randomly assigned. So half of them were in each of these conditions was randomly assigned to treatment and half to control. Actually, it looks like less than half was. Oh, actually, the height of the bar is not representing the number of participants. It's representing their different scores. So probably half were treatment and half were control. So the researcher did have control over one part, but everything else is a quasi-experimental design. The benefit of this design is that it allows us to study things that we couldn't study otherwise. Like there's no way we could study the differences between males and females if we weren't willing to use the existing groups, right? So it allows us to study things that we couldn't otherwise study. The problem is that we don't know if the differences that we see between the groups is attributable to their characteristic that we used as the sorting characteristic, like their sex, male or female, or is it due to something that goes along with that sex, some kind of confound. A good example is when you find that, there's a really good example that has to do with hairdressers. And it turns out that the bulk of hairdressers are female. And so if you find that the bulk of hairdressers don't do well on math, you may say, oh, well, it's because, hairdressers go into that field because they're not good at math. But then if you parse it out and realize that most hairdressers are female, you might say, oh, well, maybe the score is attributable to their sex rather than their math scores. So we have to be really careful about interpreting quasi-experiments. And it's really important for you as you're reading through the book to realize that a lot of the research is conducted as quasi-experimental research. Anytime that sex is the critical variable or ethnicity or what are some other really good developmental ones? Age group, right? Anytime that's being used as the independent variable, by definition it's quasi-experiment and you can't really establish causation. All right, let's go ahead and stop here because I have a few things I'd like to say about correlational research. So I will see you in the next segment.